Let's look at a 30, 60, 90. Now, you may notice right away this triangle is not isosceles. All three side lengths are different, which is what we call scaling. Scaling is when all three side lengths are different, or all three angles are different measurements. However, I'm going to do something very sneaky with this scaling. I'm going to take this scaling and I'm going to reflect it down. Now, the reason I do this is because if you look at the big triangle, this one, this is now a 60, 60, 60 triangle. Since all the angle measurements are the same, that means all three side lengths are the same. This one, and this one are all the same length. That is what we call an equilateral. An equilateral triangle has all three sides the same, or all three angles the same. Now, the reason we're going to do this is going to help us. So let's start by labeling this hypotenuse over here x. That's going to be our x this time. So if this side length is x, that means this side length is x, which means this side length is also x. Which means if this entire side length is x, that means this little side length has got to be half of x. So if this whole thing is x, then this is half of x, and this is half of x. So x over 2. So if that's x, this side will always be half of that length. So, same thing we did with our 45. If I told you the length of this is 10, you know that this one is 5. It will always be half. And vice versa. If I told you this one is 4, you know this one is 8. It's going to be twice as big. And now that I have two side lengths done, I can use Pythagorean theorem again. Where my hypotenuse is x, and one of the smaller sides is x over 2. Doesn't really matter if you do that as a or b. Now let's do x over 2 squared, which is x over 2 times itself, which gives me x squared over 4. And let's solve for this last side, solve for b. So I'm going to minus x squared over 4. And b squared equals, now if I have one whole x squared, and I'm subtracting a fourth of an x squared, I'm left with 3/4 x squared, or 3x squared over 4. Same thing. Square root to solve for b, and I get the square root of 3x squared over 4. Once again, I'm going to separate all of those roots over the multiplication and the division. And I do that because these ones will cancel, so I get square root of 3. Oh, why do I keep writing 2? Times x, and square root of 4 I know is 2. So that means this last side is square root of 3 times x over 2. And we now have all three sides labeled. So you could think of this side as square root of 3 over 2 times this side. Or you could also think of this side as square root of 3 times this side. So whatever this side is, say this side is, say, I don't know, 3. Actually, let's make it 5. This side length is 5. Then this one is going to be square root of 3 times 5, because that's what that side is. And this side would be 10 because it's twice this side. So now if you know any side, you actually know all the sides. Let's write in these patterns. So we already said if we're going from this big side to this little side, it's going to be half as big. So times by 1/2, or let's just put divide by 2. And if we want to go the other direction, we're going to times by 2. So whatever this side is twice as big. If we want to go from this shorter side to this longer side, we are going to times by √3 to make this side bigger. And if we want to go opposite, we're going to divide by √3 to make this side smaller. So whatever this side is, times by √3, it gives you that side. Whatever this side is, divide by √3, and it gives you that side. And those are our patterns for our 30, 60, 90. Now that we have the patterns down, let's do the trig ratios. So once again, let's label, go across from the right angle. There's my hypotenuse. Now notice we have 2 different angles we could focus on this time. We could focus on 30, or we could focus on 60. So let's start together focusing on 30. That's the one we'll all together focus on first, which means opposite is across from that angle. There's my opposite, and adjacent is the one left. There's my adjacent. So now that you have all those labeled, let's do our 6 trig ratios. And this is a 30 because that's the angle we're focusing on. So, same thing as last time. I'll do the first one with you, have you pause the video, and try the rest of them on your own. So, sine of 30, that is so katoa. In this case, my opposite side is x over 2. My hypotenuse side is x. And if I want to simplify this, I'm going to need to do keep, switch, flip. So I'm going to put this little x over 1. I can do that with anything. I keep the numerator, switch to multiplying, and flip the denominator. There we go. And now I notice my x's cancel, and I get 1/2. So you could even put that in your calculator. Do sine of 30 degrees, and it should give you 1/2. That will be the sine of 30 for every single triangle, as long as it's a 30, 60, 90. That works every time, no matter how big or small the triangle is, thanks to similar triangles. So now that we have that one done, pause the video and try to get the other 5 on your own. Make sure you simplify them correctly. You'll probably need to use keep, switch, flip for all of them. And then come back to check your work. Let's check your work. So these are the answers that I got for those 5. You can check what I did with my keep, switch, flip. If any of yours are different, figure out where you went wrong and fix it. Now what we're going to do for this bottom question is we're going to flip what angle we're looking at. So instead of looking at the 30, I'm going to look at the 60. So if I focus on the 60, that means this one is now opposite that side, and this one is now adjacent. Changes those two because it changes what angle we're focusing on. So now that we have those labeled differently, I want you to come down here and do sine of 60, cosine 60, tangent 60, all 6 of them, but of 60 degrees with the new focus we're looking at. So pause the video, get all 6 of those ones, and then come back to check your work. Here's what I got for our 60s. So all 6 of them right there. Once again, you can pause the video, check your work. If there's any you got wrong, look back at what I did and figure out where you went wrong. But these are the trig values for every single 60-degree angle. Doesn't matter how big or small the triangle is, these are the answers you're going to get from your calculator. Now, what I also did is I took this table that you have in the bottom of your notes, and I just copied down all the answers that we just came up with, essentially making a really nice study tool for you to reference through the rest of this semester. And they're all in one nice, beautiful place. And once again, these are the trig values, no matter how big or small the triangle is, as long as that's the angle, these are the fractions. So now that we've figured out all our special right triangles and we have all the values here, in the next video, let's start to actually do some problems where we apply this stuff. See you there.